In this video, I will show you how to solve a system of linear equations by substitution. Now, what I recommend is writing the two equations side by side first. So I will have x plus 2y equals 1. And then I will have my 3x minus 5y is equal to negative 8. So, your first job is to get one variable by itself. This x is the only variable that does not have a number in front of it. So this is definitely the one I want to get by itself. So I would subtract 2y from both sides. So that will give me x equals negative 2y plus 1. So now that you have one variable by itself, you take whatever that variable is equal to and you substitute it into the correct variable in the other equation. So x equals negative 2y plus 1. So instead of x, I can put negative 2y plus 1. Just put that in parentheses to remind you to do the distributive property later. And then finish the rest of the equation. Minus 5y is equal to negative 8. If I do the distributive property, then I will have negative 6y plus 3 minus 5y is equal to negative 8. Here I've got these like terms. So combining this negative 6 and the negative 5y, that gives me negative 11y plus 3 is equal to negative 8. Now subtracting 3 from both sides, I get negative 11y is equal to negative 11. So of course I'm going to divide both sides by negative 11. So I end up with y equals 1. So I'm halfway there. I know the y value, but I still need to know the x value. So that's why I'm going to go ahead and take this y equals 1 and I'm going to substitute it right here. So then now I have x equals negative 2 times 1 plus 1. So that's negative 2 plus 1. So that's negative 1. So x equals negative 1 and y equals 1. Or you could write that as an ordered pair, negative 1 comma 1. So that's the solution for problem number 4. Okay, let's take a look at problem number 5. Again, my first move will be to write these equations side by side whenever I do substitution. So I have x equals 2y minus 8, and then 2x minus y is equal to negative 7. So since x equals 2y minus 8, then I can go ahead and substitute this for x in the other equation. So that's going to give me 2 times okay, and I'm substituting 2y minus 8. So here goes my 2y minus 8, and then the rest of the equation. So with the distributive property, I will now have 4y minus 16 minus y equals negative 7. So 4y minus y, that's 3y minus 16 is equal to negative 7. Then adding 16 to both sides gives me 3y equals 9. So then we divide both sides by 3. And I get y equals 3. Okay, so now I can take this y equals 3 and substitute it back into the first equation. So that will give me x equals 2 times 3 minus 8. So that's x equals 6 minus 8. So x equals negative 2. In other words, negative 2 comma 3. So this would be the solution to number 5. Okay, let's do one more. And once again, I'm going to write these side by side. So I've got x minus 3y is equal to 6. And then I've got 2x plus 4y is equal to negative 2. So let's get this x by itself. Again, it's the only variable that does not have a number in front of it. So I know this is the one that I want to isolate. So I get x is equal to 3y plus 6. So I'm going to take this and substitute it into the other equation. So that'll give me 2 times 3y plus 6 plus 4y is equal to negative 2. Alright, with the distributive property, I have 6y plus 12 plus 4y equals negative 2. Now 6y and 4y make 10y. So I've got 10y plus 12 is equal to negative 2. Subtracting 12 from both sides, now I have 10y is equal to negative 14. Looks like I'm about to get a fraction. So I'm going to divide both sides by 10. So that's going to give me y is equal to, and this would make negative 7 over 5. So now we take this y value and we substitute it back in right here. So that will give me x equals 3 times negative 7 fifths plus 6. So this is like having 3 over 1. So this is negative 21 fifths plus 6. Now to add these together, I need like denominators. So I will need to multiply this by 5. So x is equal to negative 21 fifths plus 30 fifths. So negative 21 plus 30 is 9. So x is equal to 9 fifths. So this is the solution, which I could also write as 9 fifths, comma, negative 7 fifths. Notice how I'm writing this as a fraction as opposed to decimals. You should do the same. Sometimes a decimal can be exact, but sometimes you cannot write a decimal without rounding. So fractions can always be exact. So that's it for number 6.